కరెంట్ పోయిందా మీ దగ్గర? కరెంట్ పోయిందా? మురళి ఇక్కడ రా. మురళి రాడు కూర్చుందిరా. ఓకే, సో స్టార్ట్. So, where we are? Uh, so this is the cloud service valid the every request before execution. Okay. So interview में I explained right. Snowflake architecture consists of three independent layers: storage layer, compute layer, cloud services layer. So the separation of storage and compute allows independently scaling, better performance, and cost optimization. Okay. So having virtual warehouses, metadata optimization, stores the data in the form of micro partitions. You have cluster key and you have the warehouse, min, small, medium, large, x small, large, 2x, 3x, 4x, large, and clusters, vertical scaling, scale up, scale down, horizontal scaling, scale up, scale out, scaling. Okay, everything I will tell you. Okay, now we go with image, then I will explain with the image. Okay, Snowflake. Diagram. See, I said right. This is a previous one. We have query processing, right? So now they are updated to this thing, this compute layer. Okay, both are same. The name is different. So always go with the Snowflake documentation. Okay. So from here, right? From this point and click this one. First read this paragraph. Okay. Then after click this, read it, click this, read it, click this, go with it, read it. Okay. So now I display. So Shiva, are you joined?
Yes, I joined.
So we can. Mhm. Okay. Where is my these things? Okay. Mm. 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 Which okay. So here we have three layers. Okay. So one database storage layer, compute layer, and cloud services layer. Okay. So we know, right? Snowflake supports structured data, semi-structured data, and unstructured data. Structure means example. Give me anybody. What is the structured data?
Structured data is like
Structured data is
everything is
Excel,
Cleaned and
Excel,
transformed.
CSV, anything that is in tabular form.
Hmm. What is semi-structure?
Like JSON,
Hmm.
Avro file,
JSON or something.
XML files.
Hmm. What is unstructured?
Mix.
Your
Both
video,
structured
audio,
and
and all that.
semi-structured data.
Not structured CSV files. Okay, which is in the proper way. Semi-structured JSON, Parquet, Avaro, ORC, some other files, and here we're going to have an unstructured like images, audio, video files. Okay? These things in the unstructured data. Which is the place we can store all? Which is the place we can
Storage
store?
layer.
No. That
Storage.
storage layer, fine. I'm asking about where we can store structure, semi-structure, unstructured. Think out of Snowflake.
warehouse.
Where, I mean, the cloud.
Yeah. What we have warehouse, data lake, data mart we have, right?
Yes.
Where it stores structured, semi-structured, unstructured data. If you have 100 TB of data.
AWS cloud.
Yeah, S3 is warehouse or mart or data lake. S3 bucket is
Data
warehouse.
lake. It's a
Yeah,
data.
data lake. Okay. So we can store everything in the data lake. CSV, JSON, Parquet, XML, and images, audio, okay, everything. So that is the data lake. Okay. Here, Snowflake supports CSV, JSON, Parquet, XML, these file formats. Okay, these files. So CSV, JSON, images. But they are telling Snowflake also supports unstructured data. How it supports unstructured data? We cannot load, right, image or audio file or video file into the Snowflake. Then why the Snowflake company is saying Snowflake supports unstructured data? You know, while we having data in the data lake, S3, Blob, and Google Cloud Platform, we can access the metadata of images, videos, audio files. Okay, we can access the metadata. That's why they are using. They're telling so Snowflake support unstructured data. Okay, so usually Snowflake supports structure and semi-structure, and we can access metadata when it is in the data lake. Okay, so that's why they are saying like unstructured. Okay, that's why Snowflake supports structured, semi-structured, and unstructured data of metadata of unstructured data. Okay, this. So here the data stores in the database storage layer. So when we create table and insert the data. Okay. So the micro partition that I will explain later. And here this is one warehouse, this is one warehouse, this is one warehouse, this is one warehouse. Here we're going to have the databases, schemas, and tables, sweeps, whatever we have the function over there. Okay. So here this thing virtual warehouse, and here security management metadata optimization. Okay, so what is virtual warehouse? It is set of multiple computers, like multiple nodes. Okay, multiple computers, like is going to have RAM, SSD, memory, CPU. Virtual warehouse is going to have RAM, SSD, memory, CPU. Okay, so each virtual going to have set of multiple computers. Virtual warehouse. Okay, so for each process we're going to use different warehouse, different virtual warehouse. So the queries runs, loading, okay, data unloading, everything is done in the compute layer. Okay, and security management, metadata optimization. Like if you want to log into Snowflake account, you need to have username and password. Okay, simple. I will explain. Okay. Uh, Snowflake, they will ask question like what are the layers in the Snowflake? Explain about architecture of Snowflake. Okay. Then we need to go. Snowflake is multi-cluster warehouse architecture. Okay. When we create table inside data, that going to store in the database storage layer. When we run the query, like select star from table where ID is called 721, 821. So the query going to run in the compute layer. And if you want to log into Snowflake account, that will take care of the cloud services layer. And here it's like a brain, it's like a engine, it's like a basement. Okay, three. So it's clear, right? And virtual warehouse consists of it's like a set of multiple computers. So virtual warehouse are like we have small, medium, and large 1x, 2x. Yes, sorry, X small, medium, large, X large, 2x, 3x, 4x large. Okay. So total 8 sizes of warehouse. And here we're going to have clusters, 1 to 10 clusters that we will discuss while we create the warehouse. Okay. So this is completely Snowflake architecture. So multi-cluster warehouse architecture. Okay. And this is like important. Okay. So I'll keep like 1 second, guys. 1 second, guys. నోళ్ళ తీసుకో.
లేదన్నా.
ఓకే. థ్యాంక్ యూ. సో it is like shared disk architectures. Okay, open notepad. Snowflake is we have like so multi-cluster, multi-cluster. Okay, we can say shared, okay? Shared disk architecture. It means what is first one? Shared disk architecture. So I'm going with some in depth. Okay. Okay. See here all servers. So like servers means nodes share the same storage. Okay. It's like a disk. Share the same storage disk. All servers, all nodes share the same storage disk, and every node, okay, every node can access the same data. Every node can access the same data, and here so easy to maintain. Like consistency, we have data consistency is the very important, okay? And easy to maintain a consistency. And if I think it is new to you, I will explain. The shared storage files fails. Sorry, like if the shared storage fails, so the entire system can be affected. Okay, okay, like a single point of failure. If any having like a single point of failure. Okay, if I have like this one. Okay, if the shared storage fails, the entire system can be affected. Single point of failure. See, so here shared disk architecture. So all servers and all nodes share the same storage. All servers nodes share the same storage disk. Okay, here every node can access the same data. Easy to maintain consistency. If the shared storage fails, the entire system can be affected. Okay, single point of failure. Okay, now how we need to manage this. Okay, so now we have see I will give an example. So think like Oracle. So okay, RAC here. So we have node 1, node 1, and node 2, and node 3. So here okay, all share storage. But this is shared storage. Okay, all are storing the same disk. Now, so move to next one. So second is shared nothing, nothing architecture. I think for few people it's new, but learn. If you want to work like hard tech, admin, developer, analyst, tester, into know. Okay. must admin, sorry, architect and admin. Okay? So we need to know everything for architect and admin. Okay, and everyone need to know. So about Snowflake, we want to work with the Snowflake. So shared. So here we go on with shared disk architecture. This is shared nothing disk architecture. Shared nothing architecture. Shared disk architecture. Shared nothing architecture. Shared nothing architecture means like every server so has its own okay, its own like we can say CPU. Okay, so own CPU, okay, and memory and disk. Okay. Then here no storage is shared between nodes. Here data is partition. Sorry, data is partition across nodes. Data is partition across nodes and here like highly scalable and avoids storage bottlenecks that we see in the query profile bottlenecks that I will explain in that time. Okay, so see every server in shared nothing architecture, every server has its own CPU, memory, and disk. No, okay, no storage is shared between nodes, and data is partitioned across nodes. So highly scalable and avoids storage bottlenecks. Okay, so examples. To give examples, right? What are the examples here? We have Teradata and Greenplum and Apache, Cassandra. Okay? These things we have. Okay. So here node one. Okay, node one is like a CPU plus memory, memory plus disk. Like for node one, we're going to have this thing. Some copy this thing, paste here. So node 2 also going to having CPE, memory, disk, and again node 3 also going to have CPE, memory, disk. Okay, and then come to third one, Snowflake multi multi cluster like multi cluster shared data architecture. It means Snowflake multi cluster shared data architecture. It means like here, see how Snowflake is going to shape this. Okay, so Snowflake combines the advantage of both approaches. Snowflake combines both approaches, both advantage of advantages of both approaches. What is the advantage in the first approach? What is the advantage in the second approach? Tell me. First advantage is like so share the same disk is every node can access the same data, easy to maintain consistency. Okay. Second one is everyone needs have their own CP memory and disk. So, but data is partitioned across nodes. Okay. So those are advantages. Okay. So Snowflake combines the advantage of both approaches. Here, how it approaches. Like storage is shared, okay, across, okay, all virtual warehouse. So each virtual warehouse is independent, but storage across shared all virtual. How it will shade all across? Because of we have separate layer for storage, right? So that's why storage is shared across all virtual warehouses. And compute, you have compute, right? Compute is independent. Okay, it share the data, not compute, and separated from storage. Compute is independent and separated from storage. Okay, then uh, multi. We have multiple virtual warehouses, virtual warehouses. So can read the same data simultaneously. Okay, same data. Okay, simultaneously. Simultaneously. Okay, here is it. So multiple virtual warehouses can read the same data simultaneously. So each warehouse has its own compute resources. So workloads do not interfere with each other. Okay, cloud storage there. Okay, here simple will type. See, think like cloud storage. Here comes like shared data layer. Okay, shared data layer. Then to this one. Okay. Here comes like I- okay. So here this comes like a cloud storage shared data layer. Then okay, here you see what we are going to have like take like one, okay, three. Okay. So warehouse, okay, one, okay, and warehouse two, and warehouse three. And here it's like compute. I don't have picture of this one, even I didn't see. Compute here, virtual warehouse, one compute, and it also. So here, see, you're getting my point, right? What I'm explaining. See, cloud storage, shared data layer, and whereas one compute having separate, whereas two having separate compute, and whereas three having separate compute. So everything, okay. This is okay shared data layer. This is the cloud storage shared data layer. But each virtual warehouse can access these shared data. But there is having every warehouse each separately like compute power, separate compute power. So why Snowflake better? Yeah, why Snowflake better? See, I will explain. Why Snowflake better here? Why? So compute and storage scale independently. Compute and storage, okay, scale independently. and here no data duplication, no data duplication, and high concurrency. What is high concurrency? Anybody? Many users. Okay, many users work. Okay, work at a time, run queries at a time. That is a concurrency. So that we can mention. So per at a time, how many queries we can run? Or 20 or 10, 30, 40. We can mention that is in the while we are creating the warehouse. That is high concurrency. Then so we have like better performance equal to better performance. And then cost optimization we have cost optimization. Optimization. So like pay separately for storage and compute. So you can check compute. So this is okay. So why is Snowflake better? Computer storage scale independently, no data duplication, high concurrency. So at a time, so we can run multiple users can run multiple queries, better performance, cost optimization, pay separately for storage and compute. So this thing. And here we have nodes, right? So what is a node? What is a node? Anybody having idea?
Node is a system
Yeah.
in a virtual warehouse. Is one unit.
Node is a simply a server or computer that processing the data, and it means it won't process that. Okay, node is simply a server computer that involved with in processing the data. Simple definition: node. I'm giving like one simple definition. Node, one server with its own CPU, memory, RAM, and sometimes storage. I said right. What is virtual? A set of multiple computers, set of multiple nodes. That thing I said already. Set of multiple computers like having CPU, memory, RAM, SSD. That virtual is having like that. Set of multiple computers, that is we know, and a set of multiple nodes, that is Snowflake inside. Okay, that is node. That is like this is a set of multiple computers like easy way. Set of multiple nodes in like professional way, like a Snowflake professional way. Like okay, simple. Node is a one server. Its own CPU, memory, RAM, and sometimes storage disk. So example, imagine you have three servers. Okay, here one is like node one. కూర్చొని టీ తాగుదాం కూర్చొని ఏ 2 minutes కూర్చో అయిపోయింది క్లాస్ అయిపోయింది కూర్చొని సో నోడ్ 1 like 16 think like 16 CPU and 64 GB RAM and node 2 like again having same thing 16 GB, sorry, 16 CPU, 64 GB RAM, like that. Okay, so like that node 3 going to have, so node 3 also going to have 16 CPU, 64 GB RAM. Okay, so you have three servers. Okay, server 1 node 1 16 CPU, 64 GB RAM. Server 2 node 2 16 CPU, 64 GB RAM. Server 3 node 3 16 CPU, 64 GB RAM. So together they form a cluster. Okay, together they're going to form like cluster. So I will explain what is the cluster next class. So cluster, okay, and node 1 server. Okay, then here think, so node 2 server and node 3 server. Okay, remember, okay, these flow. Okay, so no, it will take time. Okay, so simple time. Okay, cluster node 1 server, node 2 server, node 3 server. Okay, so in shared nothing, so each node has its own resources. In shared nothing, in shared disk all nodes share the same storage. Okay, Remember, in shared nothing. In shared nothing, each node has its own resources, like node 1 CPU RAM disk, node 2 CPU RAM disk, node 3 CPU RAM disk. In shared disk, first I told about in shared nothing. In shared disk, all nodes share the same storage. So node 1, node 2, node 3 going to share CPU plus RAM plus disk shared storage. Okay. So in Snowflake, a virtual warehouse consists of one or more computer nodes. Okay. In Snowflake, a virtual warehouse consists of one or more computer nodes. So X small warehouse, one compute node, larger warehouse, multiple computer nodes working together. Okay. Remember, we'll type in Snowflake. Okay. One consists of one or more. One or more nodes compute nodes, okay? And x small, think x small whereas think like one node and larger warehouses. So USEC larger warehouses like multi LTMP multiple compute nodes. So here, multiple compute nodes working together, and all compute nodes, all compute nodes. So access the same centralized cloud storage. Okay, remember in Snowflake, okay, say in Snowflake. Sorry, here I'm going to mention a virtual warehouse. So in a Snowflake, a virtual warehouse consists of one or more computer nodes, and XML warehouse one compute node, and larger warehouse multiple computer nodes working together. So all compute nodes access the same centralized cloud storage. So how are you going to answer this in the interview? A node is a physically or virtually server that provides CPU and memory to process data. Multiple nodes work together as a cluster to improve performance, scalability, and fault tolerance. Here, node. So node means like if you are 16 GB RAM, okay, and if you are adding one more node, it is like 16 GB RAM. Okay, one more node you are adding 16 GB. Okay, 16 GB RAM totally equal to 48, 48, 48. Okay, 32, 38, 48. Yeah, okay, these 48 RAM. Okay, if you want to increase the power of the virtual warehouse, we need to add the nodes. Okay, this thing. And what is a cluster? So while you are driving the car, so you're going to change one to second gear, third to fourth gear, right? So those are clusters. Like if you increase the gear, if you add the gear, it's going to go to high speed, like third, fourth gears. And if you add the clusters, if there are many users, it's going to work with more power to handle all queries. And if there are many users, that is the clusters. That we will see in depth when we go with the warehouse creation. And the final one answer, we will end the class. So how are we going to answer in the interview? So traditional databases uses either shared disk or shared nothing architecture. Shared disk shares storage among all nodes, while shared nothing gives each node its own storage. Snowflake uses multi-cluster shared data. Okay, wait a second. Okay, sorry. Snowflake uses a. So once again, I will repeat. Traditional database uses either shared disk or shared nothing architecture. Shared disk shares storage among all nodes, while shared nothing gives each node its own storage. Snowflake uses multi-cluster shared architecture where all virtual warehouses share the same centralized cloud storage but having independent compute clusters. This provides excellent scalability, concurrency, performance, and cost efficiency. Okay, this is. So this is guys. Okay. So as of now, it's clear, right? Anybody having doubt? There is only 1 minute. Any doubt? You can ping me in the group. Okay. Thank you. Have a great day. Bye.